Good morning, everyone. Announcements first. This week you have another assignment. Assignment 4 is all about unit testing. We're going to talk about it, but you have an assignment, unit testing. Second, this week also, I open for you a new sample exam as usual, like the previous one. The goal is an exam that is only one question. The only goal, test your lockdown browser. As you mentioned in the chat, next week you have the second midterm. Next week we do not have a video lecture. Next week, during the time of the lecture, you go and when your exam, you need to have lockdown browser used as in the first midterm. I think you remember the process, you know what to do. So another sample exam, test your system, even if your system worked before, but if for any reason you install a new driver, change something, software, I do not know, it's just 1 second, 1 minute, test your system before the exam. Next week, the exam is going to open, as I mentioned, lockdown browser during the lecture time only, and also after you finish the exam, it's going to open exercise 6. Exercise 6, which means even though we do not have a lecture, you have homework. Your homework is going to be about cyclomatic complexity, some videos, some exercises. With those two, assignment 4 and the exercise 6, something that I want to point out is right now, as usual, assignment 4, this one due Wednesday before the midterm, that do not change, and exercise 6 also due Wednesday before our next lecture, as usual. Now, after you finish exercise 6, which means next week, hopefully, we have done 2 quizzes. It's going to be 4 assignments, and after exercise 6, it's going to be 6 exercises. A quick note, quizzes and assignments together are 20% of your grade. Exercises are 20% of your grade. So you can review this on the syllabus. My point is, after you finish this, every single quiz, every single exercise is this value. So something like 3.x% of your final grade. Some of you ask me, how many points if I didn't submit an assignment? How many points if I didn't submit an exercise? Well, more or less, this is your answer after exercise 4 and exercise 6. Don't worry about the review. I am going to talk about your question in the exam in my next slides. So, homework for this week, assignment 4, due on Wednesday. Test your lockdown browser with the sample exam. This is for this week. Next week, you have the exam during the lecture time, and after that, you have another exercise, and that is your homework, and we will meet in 2 weeks from now to continue. Good. And another question that I received is about your project, your final project. I am going to talk about your final project in our next lecture. That means after your second midterm. So that is something coming. That is more or less our schedule. This week, next one, and then the final project is coming. Good. So important, just for you to remember, it's an exam. There is a document that is going to be posted this week with the sample exam about guidelines from ASU regarding what you can do and cannot do during the exam. Please read the guidelines. The most important one, the most flag that I received from your first midterm, you cannot use headphones during the exam. Some of you need it at the beginning because you need a microphone. You can use when you are doing the setup, running things, configuring things. When you start answering the questions, when you are in the exam, after all the environment show and so on, remove the headphones. if you need to have them at the beginning. But best case scenario, do not use them at all. That is the most of the flag that I review for the previous one. Good. So check this, be careful, understand, review, any question, let us know. The exam, the second midterm is used as the first one, closed book. Also, as we mentioned in the lecture one, is a comprehensive exam. Comprehensive is going to include questions like the ones that you already answered. And I am going to talk more about it in the next slides. Closed book, you cannot use your notes. Remember, you'll be recorded. The audio has been recorded. Whatever movement people in the room on, be careful. It's just like being in the classroom, win your exam, be responsible, be ethical. A scratch paper is allowed. You can use a scratch paper just like before. Just remember, please show the paper to the camera. Empty paper. Do not use recycled paper. Do not use paper that have something printed or written. Empty paper. And it's okay to use it. Probably for this one, it could be a good idea to have paper with you, because some of the things that you're going to do is diagrams and coding. Some of you could need to write things. As before, the exam is multiple choice questions, and in this case, open questions mostly related with programming. An open space in which we are going to ask you for a couple of lines of code, 1 or 2 lines, or a small program, a small function. Nothing that you need to take a picture or upload files or something like that. Multiple choice, open questions, writing small things, or use select checkboxes. That is basically what you are going to be doing. I think you need 1 or 2 pages. I mean, it's not like you're going to do a lot of things. Probably the answer for that question is more like up to you. I mean, how big is your letter, or how big you do your squares or things like that. I would recommend 2 pages, 4 maybe. I mean, you do not need like a full package, right? Something between 2 and 4. You remember, show to the camera. Now, I am sure that you're going to send us email during the week, to me, to the TAs. As before, please remember, if you send us an email, do not forget to mention which course, 360. Please include your section. We have 2 Tuesdays. So please mention your section, so we know, like, if the question is about a due date, we know which is the section, which is the class, and therefore we can answer your question about the due date or review your grades or whatever. If the question is in particular about a grade, the first thing that you need to do is to contact the TA. I have a question, I need more feedback, I need an explanation, whatever. Please be polite. Remember the etiquette. If the TA or the grader make a mistake in grading your exam, if they didn't put a particular feedback, it's not because they have something against you in particular. They have a lot of people grading, and when they are grading, they are not reviewing who is this guy or who is this lady. They are just grading, and they can make mistakes. So you can send an email and just ask, I didn't have feedback here, or I have a question, and they are going to follow up with you. If you want to include me in the email, like in the copy, it is fine, but it's not needed. They are very good answering emails. Usually allow them at least 24 hours to follow up with you. You are more than 200 people. So even though if they want to answer your emails immediately, like in a couple of hours, sometimes it's not possible. So 24 hours, if you do not receive an email, you can send a follow-up. It is fine. Medical conditions, usually before the exam or during the exam week, the medical conditions increase exponentially. I am aware of that. Please, if you are going to contact me about a medical condition, just remember, I do not need to know the details of your condition. That is private information. The only thing that usually happen is if you visit health services, ASU or whatever, they usually give you a note, a letter, a piece of paper that indicate that you have some particular condition, some particular situation, and you are unable to work or to be in the school for a particular period of time. Usually that is just good enough for me. I do not need to know your particular health situation. Again, that is private information. If you want to share with me, it's fine, but I am just telling you that information, the information regarding your health situation is usually private. It's something that you do not need to share with me or with someone else, but visit health services. If that is the case, contact me, not the TA. And always, 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 please, your ASU email. If you send me an email, Hotmail, Gmail, Yahoo, something like that, I have no way to know that people is you. Therefore, I am not going to share information about grades or other personal things. Use your ASU email. Similar rule apply with the TAs. Moving forward, I want to start today with the review. I received questions about what is going to be on the exam. So I want to share quickly before starting with our last topic, what is going to be on the exam. Number one, the exam cover lectures 1 to 9, which means from the beginning to what I am going to cover today. Everything is a comprehensive exam. Now, the second question is, well, how many things from the previous one and how many things new in the exam? My answer usually is, if you think about the exam 1 and the exam 2, I can tell you that at least 30% of your exam, I am just using numbers to give you an idea. It's not a promise like 30% of your grade is going to be about something. But about 1/3 of your exam, 30%, is going to be questions that come from the same pool that your first midterm, which basically means that 33% of your exam, the questions are going to be from the same pool. Could be one question that you already answered, or one question that was not in your exam, but maybe was in the exam of your friend. You're going to notice, several people notice this, is like, oh, this question or a very, very similar, I already answered this in the previous one. That is going to happen. It's not an error. It's going to be in that way. So my first recommendation is go and review your first exam and be sure that if you are asked the same questions, you are able to do it correctly. If you get an A+ in the previous exam, that is great. You can get 30% of points easily. But if you didn't do that, if you get 80, 50, 60, or whatever grade you have, review the questions in which you fail. So if that question is again in your second exam, this time you can answer that correctly. I am going to mention the topic, so don't worry. 30% things that you already did. The other 30%, for sure, new things. And I am going to tell you which new things. But if you remember, we have the midterm around the lecture 4. So you can more or less imagine what is coming that is new. I am going to give you the topics. So that gives me this 30% here. That is an intersection. There are things that we review before and after the exam, particularly class diagrams. I make a particular point here because class diagrams, going from the diagram to the code, from the code to the diagram, the relationships, and moving forward, the patterns, the programming of the patterns. I am talking basically about your previous assignment. That is going to be a very important part of your exam. I separate that part from the other 30%, that is requirements, concepts, process models, and so on. A very important part from previous things that we cover that you need to review, and it's kind of obvious because it's also the beginning of the second new things, class diagrams, and patterns. Very important. So this is kind of your big picture for the exam. 1/3 things that I already reviewed, 1/3 class diagrams, patterns, programming, 1/3 new things, other new things, most of them conceptual and theoretical background. In specific, the topics as follow. Disclaimer, I am going to list a group of topics from the exam one and from the new one. The topics that I put here is just the one that I consider the most important. It's not a comprehensive list of topics. For the topics, go and review the lectures, at least the slides. Any question in your exam was mentioned during one of the lectures and therefore is in one of the slides, or was something that you did as a homework. Therefore, if you already did that as a homework, you can be asked to do the same in your exam. For instance, pseudocode, for instance, a flowchart diagram. Questions very similar to the ones that you already answered when you submit the homework. So those two sources, your homeworks and the lectures. All the videos are posted, but the slides also, you can check the slides for a list of topics. In general, the most important, but not a comprehensive list. For the first exam. For the first exam, you can expect, again, questions that involve concepts. What is software engineering? What is a model? What is software design? What is a requirement? What is a functional requirement? What is a non-functional requirement? What is a process model? What is a process? What is an activity? All those kind of questions, and I just mentioned examples, can be there again, obviously multiple choice. So it's not about you writing, but it's about you selecting the correct answer. Process models, again, for the following project, a description of things, which is the process model that you will apply. Please review that from the previous exam. When to use waterfall, when to use B-model, when to use spiral, agile, incremental, and so on. Review the process models. Which are the characteristics of the process models? Which is the difference between waterfall and B-model? They are the same? They apply for the same projects? Yes, no, obviously no. Which is the particular characteristic of one of them that will make you to choose that one for a particular problem? For sure, these questions are going to be there. And these questions are going to be there. Requirements, maybe the most important thing, which is the difference between a requirement and a necessity, which is the difference between something that the customer asked me to do and what we call a requirement. Hopefully you remember the validation part, clear, unambiguous. There is a slide with a list of things that maybe you want to review if you do not remember them already. Now, connected with requirements, something that we review, something that you did in homeworks, user stories. Probably in your exam, you're going to have a user story, or you are going to be asked to select a user story or to write a user story. Use cases. And talking about your cases, for sure, the two most important things that we review with use cases, well, at least the most complicated one, the tricky ones, include and extend. Remember, two use cases, the line that connect them. When we use include, when we use extend, there is a slide with a table and particular questions that you answer, and those answers give you the selection of, oh, this is for an include, this is for an extend. Highly recommended, review that. You can have questions about it. Moving forward with requirements, something that you did in a homework, activity diagrams and state diagrams. Questions that could be as easy as this diagram. What type of diagram is this one? It's a picture and you need to tell me if that one is a state diagram or use case or activity. Just for me to know that you did your homework and can remember how the diagrams look like. Now, sequence diagrams are going to be included. So you can expect having sequence diagram as an option in the questions. From that to which is the correct diagram for a particular thing. A description, and your options are diagrams, or the opposite, a diagram, and the options are descriptions, and you need to do the match. Review, activity, state, use case. Questions can be as easy as, what is the meaning of the diamond in an activity diagram? What is the meaning of the circle or the box in particular diagram? Just remember the notation, you remember how the diagrams look like. Finally, something that we reviewed in the previous exam, some questions that can appear again in your exam now. Class diagrams, the questions from the previous exam are very simple, like this line with a triangle at the end is, and you answer, or these small pieces of code, two classes with one variable, and the question is which is the relationship between those classes. Very simple, very small, at least that is what we cover in the first exam. Review this. This could be the most important thing, but again, my recommendation, open your exam, review every single question in which you fail, so you are ready to answer the same question again, but hopefully this time correctly. Moving forward, new things. And I am going to cover here new things, both the fully new and the intersection. So 66% of your exam is about the following 10 topics. I have 2 slides, these 5 and another 5 later. So new things, sequence diagrams. Sequence diagrams, similar questions to the one that you had before regarding state and activity. From something simple like showing you a sequence diagram and asking you, what is this? And the options are obviously sequence diagram and others used for distraction, or to give you a problem like the problems that you have in your homework and ask you which of the following diagrams show that a solution for that problem. Review your homework. The things that you did for the homework in the sequence diagram could be questions that you have again. So moving forward, and you did a homework regarding version control, you did a homework regarding GitHub. From this, we are not going to ask you anything like practical things. It's going to be more about theoretical background, that you understand what you did, how did it work, what is important. Basically, my recommendation here is watch the video again in which you learn about this, remember what you did, and some keywords like you did commits, and what is a commit in terms of version control, what you did, what happened. You create a class and then you modify the class and something happened there. The version control system did something for you. What was that? Just if you did your homework, if you submit your homework, if you understand what we ask about, share with us your URL for the repository. If you understand what is this repository and these commits that you did, that could be used good enough for the exam. Is a topic that is going to be there, one question maybe, is not something that is going to be a lot. One lecture, we review abstraction, encapsulation, polymorphism, cohesion, and coupling. This lecture in particular, if you want to take a look, a lot of questions, theoretical questions here. You can imagine in your exam, what is abstraction? What is encapsulation? What is polymorphism? Which of the following source code show polymorphic behavior? Things like that. Cohesion, coupling. Which one should be low and which one should be high? We have, or we recommend low coupling or high coupling? High cohesion or low cohesion? And what is the meaning of that? The one that is correct. And why that is recommended? Those are the questions that could be there. Those are the questions that we answer during one particular lecture in which we talk about the object-oriented principles. Take a look and be sure that you remember or can identify the concepts. Again, these are not going to be open questions, multiple choice, so you do not really need to memorize the definition, but you need to remember the key element that can help you to identify one option or the other when you are asked in a multiple choice way about what is some of this. Or the opposite, if I give you a definition and the options are the concepts, select the concept that corresponds to the definition. Check that one. For the design patterns, as I mentioned before, a very important topic for your exam, particularly you want to review your assignment next week, your assignment about programming. For the observer and the decorator pattern, please review the UML diagram. Be sure that you understand the UML diagram. You understand class diagrams. In particular, be sure that you review and fully understand the class diagram for these two patterns. Moreover, coding. If we have an opportunity to ask you questions about programming, this is the place. Programming with patterns or programming the patterns. Review the source code and the diagram for those patterns. And there is a full lecture in which we work with that. So if you need it, go and review the video, at least go and review the source code in the slides. That could be material that we can use for questions. A lot here. And finally, homework for this week. I asked you to do some homework regarding algorithms, in particular, easy things, a lot of easy things, hopefully. Decision tables and decision trees, you check some videos about it, you did an exercise about it. So hopefully I can ask you during the exam about using or creating a decision tree. Obviously, not everything, but again, several options, select the one that is correct. Or I can give you a decision table and I can ask you about, okay, according with this decision table, what is the result of this? Similar to the things that you did as a homework. Or something as simple as, what is a decision table? And a group of definitions. Review your homework, be sure that you did your homework. If for any reason you didn't do your homework, be sure that you review the topics. What is a decision table? What is a decision tree? Why they are useful? And if I give you one, be able to answer questions related with that decision table. Along those lines, diagrams, flowcharts, diagram, NS diagrams, as simple as this diagram here, picture, is a flowchart or an SS diagram. Okay, this is a flowchart or this is an SS diagram, which is the equivalent from the following. Both represent algorithms in a very different ways. Hopefully you notice, hopefully you learn about it. They are modeling the same information. Can we have an equivalent? One category from the other category? Can you identify which one is? Hopefully, yes. And in the same direction, pseudocode. At this point, what is pseudocode? A group of definitions. Hopefully you understand that. You review that in the homework, and there is a connection here from pseudocode to the flowchart, from the flowchart to pseudocode, and obviously the same connection there. The previous one, decision table, decision trees, is only to understand conditions. It's something that you hopefully check and review and learn. But these three, to represent the algorithm, to represent what you have inside of the method. So we can play with those three in your exam, moving to translate one to the other. Even though I am listing this algorithm thing in 3 different points, that doesn't mean that there is going to be a lot of questions about this. I just separate the topics, those 3 topics separated, but the questions are going to be more or less the same, that question regarding another topics. 3 questions, 2, 4, depending on your exam. Remember, randomly take it from a pool of questions. Now, algorithms. Obviously, previous lecture, we talk about software architecture. Most of the things that we review about software architecture is theoretical background. What is software architecture? What is the difference between software architecture and software design? Those 2 questions, for sure, in your exam, they are key. Moreover, if we talk about architecture, we talk about architectural patterns. Architectural patterns, we review a couple of them. For sure, MVC, what is that? Client server, what is that? Blackboard or repository, what is that? And layers, what are they? Review the slides or the lecture from the previous week. questions in your exam. Most of them, again, theoretical concepts, things that you need to know. Architectural patterns, the one that I mentioned. And finally, the last topic, software testing. That is what I am going to review with you today. We're going to review probably only half of the topic, 50%. That is what I have in the slides. After your exam, the next lecture, in 2 weeks that we meet again, we're going to continue with software testing, and we're going to talk, as I mentioned before, about your final project. That is going to be the content of our next meeting. So, as a summary, a very big picture, these are the topics that I recommend you to review during the week before your exam. Previous topics and the new things that we review for this second midterm. Good? Okay, questions in the chat. I am not going to ask you to draw anything. I do not want to have you drawing things and taking pictures. And the software, the Canvas, the lockdown browser didn't allow me to request you to draw things. The facility is not like there. So for the diagrams, usually you're going to have the picture in the question or in the answers, and it's going to be select one of them. So it's going to be more about review the diagram and then connect the diagram with some kind of definition in the answers, or it's going to be about having the problem and all the answers are different diagrams. So review them and select one instead of having to draw the diagram yourselves. Hopefully that is useful. Like you have the elements there, and the only thing that you need to use to discriminate is the different connections. I mentioned a poll. Your exams, when you receive an exam, each question in your exam is not the same that the questions in the exam of someone else. What the system do, Canvas, is the TAs and myself create a pool of questions, a group of questions, and when you enter to the system take randomly questions from this database, this pool, and that create your exam. So sometimes when you ask me like, I have a question in my question 7, well, your question 7, I do not know which one is your question 7 until I enter to the system and review your exam. But use like that, question 7 for you can be different from question 7 from other people. It's random. Good? Okay, great. Answer for the exercise 5. I think the graders are working on that. Usually you have news about grades release at the beginning of the week, but if you have a particular question about when you can have answers for exercise 5, my recommendation, contact the TA. They can give you an exact date according with the work that they have. But my understanding is that usually at the beginning of the week, I read emails, notification that they are posting grades. So talk with them. Assignment 4 usually appears on Canvas by noon. I mean, it's scheduled to be released. If you have any problem accessing the assignment afternoon, you can contact me. And the only reason because I am asking you to do it after noon, after 12, is because finishing with you, I have another lecture. So if you send me an email immediately after the lecture finish, probably I am not going to read it until like 12:15 or something. So if you have a problem, let me know. But should be there. Good. So this is your exam. This is for the next week. Moving forward, software testing. That is, again, is included in your exam. Is something easy. I want to review it with you quickly. So software testing. Number 1, where we are. Software activities. Something that we did in lecture 2 is to talk about the process models. The process models is how these activities are connected. Something that we review is one way or another, all the process models, all the different ways to create software include one way or another these activities. And we talk about these requirements. Our first lecture, lecture 4, what was a requirement and the diagrams and so on. Then we move from requirements to modeling, in particular design. And we talk about software design, design patterns, and software architecture, architectural patterns. Those things are here. Now we need to move to the next level, to the next activity. The next activity, coding. Well, you are programmers, you're good with that. I do not want to talk about this. I want to talk about this. You already know coding, right? Testing. Testing is the next activity that I want to review with you. What is that? What we need to do there? Knowledge that I need to have about testing. So talking about testing, number one, the definition. Important thing, guys. Software testing is about two things, two activities. Number one, validation. Number two, verification. When you do software testing, activity number one is, you are looking for errors. Let's use discover defects. Fancy definition. You are looking for bugs. You are looking for errors. But that is just one part of what should be, what is software testing. Looking for errors, what you do when you run your program or you are checking your code, whatever, that is verification. You are verifying that whatever you program, your code, do not have bugs. Okay, but the other part of software testing, the part that sometimes we forgot, is validation. Validation. You do a piece of software. Okay, you can achieve that piece of software with zero errors, no bugs. Your program works. Your program do something. The big question is, that something is what the customer asks. You can have a piece of software with zero errors, a beautiful, perfect piece of software, but the customer asks for something else. And this one is not correct from the point of view of engineering. Your goal is to satisfy the customer. Even though this piece of software is perfect, beautiful, great, if this piece of software is not doing what the customer asks, it's not correct. And that is what we call validation. Validate that the software do what the requirement asks, that the software is connected with the requirement, validation. Found the errors, verification. Software testing, both activities. It's not enough to have a piece of software with zero errors. We need to show that this piece of software connects with the requirements. Do you remember that one of the features of the requirements is every single requirement is a requirement because it's able to be tested, it's able to be measured. Measured, tested, because we want to validate that that requirement was done. And we do that during the software testing phase, during the software testing activity. It's not only about found bugs. Yeah, it's a very, very good idea. The point is, it's a very good idea. It can be applied to several different projects. Talking about self-driving developing is great. Unfortunately, for some kind of projects, for some type of projects, do not apply. And that is a topic for a different course, but it's great. If we can apply, if you can apply, if the company can apply that, is a very good idea. You start with the testing and then you create the software. Usually the order is connected with the software process that you are following. Remember, if you are doing Agile, well, your validation verification is connected with those things that you select for your sprint backlog. If you are following a different thing like waterfall, well, usually your validation verification is connected with the priority of the requirements or with the things that you already have implemented, or the most important things that you have. Something that we're going to review, I'm going to mention at the end, is top down, bottom up. You start reviewing things starting from the top, the main, and go down, or you start reviewing the components, the units, and then you start putting together units until you get to your main. So top down, bottom up, it used the classical way to do things, but there are other ways, and always depend on the project and the process. And we are not going to review that level of detail. There is a full class of software testing for the graduate level or the 400 level. Theoretical things here. Anyway, verification, validation. Remember those two words for your exam. Question in your exam. These things that I put in the slides in blue or in red is kind of, I am going to be in your exam, kind of that. Anyway, so testing. One important thing, when you do testing, the testing tells you that you have an error. You do a testing, you check your program, and well, sometimes you have errors. That is the only thing that you get with testing. But to be clear, testing is not a guarantee that your program do not have errors, unless you do a full 100% checking of everything, and that never happened. Guys, doing testing is a very expensive activity, and the number of combination of things that you need to test in a program is exponential. No piece of software, well, unless involve human lives, and I put quotation marks, is tested 100%. Sorry. And you leave that as a user every single day with the operating system. The most important piece of software in your computer is the operating system. And it doesn't matter if you're using Windows or Mac. They didn't test everything. In fact, think about it. I check some things, some parts. I am going to talk about parts later, and I release the product. What happened with the other parts? What happened with the things that I have no chance to test in detail? The user is going to test it. You're going to complain about an error, and then there is going to be a patch later in the future. Why? That is cheap. You are the user, but at the same time, you are the tester in one particular level. That happened. It's impossible to test everything, most in complex systems. Now, thinking about testing, two options. And option number one, as usual, in your project for your teams, if you're developing software, if you're going to be doing a final project, usually the developer, the same people that is doing the program, do some testing. Well, at least that is what I expect, right? In a company, they expect the same. You do a piece of software, and at least you're going to do some testing to check that what you did is working, at least in the normal, common, trivial scenarios. To be honest, the testing that you're going to do as a developer, one is going to be very, very shallow. Why? Because we do not want to crash our own software. Number one, we are confident that whatever I did is going to work, so I do not need to test. And if I test, it's going to be a testing that is like, oh, something simple or trivial, my little piece of software, I do not want to harm it. It's going to be gentle. Moreover, what I want is to submit. I mean, I want to submit my project. I have other projects to do as a student. So this is working, run one time, work, two times, work, submit. Or later, maybe the TA is going to crash that software. Why? Because the TA is like an independent tester. And an independent tester is basically someone that didn't create the software. And did someone that didn't create the software, like the TA with your project, his goal is to break it. Think about it. If I ask you to check my code, the first thing that you want to do is, I want to be the one that found a fail here. It's like your goal instead of something extra. In a company, usually in a company, big companies, you can apply to be a developer or you can apply to be a tester. At least those two roles in the companies that develop software. I am talking about Silicon Valley. Two different roles, two different employment things that you can have. And let me be clear, the tester is not someone that is just running the program. It's someone that is developing software for doing the testing. And in particular, I am talking about developing at least unit test cases. The software that is testing the software that someone else did, the tester. And here, talking about testing, different levels of testing. Different things that this guy can do. We're not going to talk about all of them, but quickly, the three most important levels, the three things that you need to remember. When you want to test a piece of software, the basic thing to do, unit testing. What is unit testing? Unit testing is test your units. Okay, which are my units? The small parts that conform your software. Which are the small parts that conform my software? Well, you can start with something that's simple as a function. Think about it. Your algorithm is inside of one function or a group of functions. The first thing that you want to test is that function, if the full algorithm is in one, work. But sometimes that function needs another one, right? Because this one is calling this one, and the two are connected. The two need to be tested together. Well, your unit is those two functions together because you need to test them together because one needs the other. So you call unit to those two. Well, wait, but they are in a class and they need variables from the class. Okay, in that case, your unit, if you need to test it together because they need global attributes and also the functions, your unit is going to be this class. Wait, but this class is connected with a diamond and is a black diamond to another class. Do you remember? Diamonds are strong relationships. Moreover, black diamond is a very strong relationship. The problem with the black diamond is here in testing. I need this class, and if it's connected with another in a strong way, when I want to test it, my unit is those classes together. Again, the minimum thing that I can test in an independent way. Hopefully, one method, one class, or a group of methods, or a group of classes. I am including here functions and classes because, well, most of the things that we're doing is object-oriented. But remember, object-oriented is just one paradigm here. We can do software in C, and there are no classes there. Only functions in files. So unit, functions, classes, group of functions, group of classes that need to be tested together because they are dependent. Now, when you test a piece of software, you start with this, testing your units. When you move forward and you have some units that are working, like my unit A and my unit B, they work separate. I am sure that this screen is working and I am sure that this keyboard is working. Okay, can you put them together and see if they can work together? Something that I need to be sure that we understand. If you have two components and those components work separate, that doesn't mean that they are going to work together. Because always, an error can be in the connection of the components. Your software works, and the software from your friend works, and your other friend is also working. You are doing a project as a team, and you are three, and your software in your computers work. When you put together and submit with the TA, it didn't work. I am sure that you have lived this experience, or at least heard about it. Integration. And there is a particular area, integration testing, the second step. We put together units, we test that they work together. Hopefully they continue working until in some point we reach the top. I am not going to cover this part, but acceptance testing, basically to check that everything together work, and acceptance is this idea that the customer is going to accept the project because finally the integration of everything shows that all the requirements are there. What we're going to cover here, the most important thing is this one for today, and we are going to mention a little bit about integration testing in our next lecture. Today, unit testing, moving forward, that is my topic, unit testing. Now, unit testing, the testing of the units. two different ways of testing the units. Two different ways. Number one, my unit, and I am going to represent the unit as a box. You can have the source code or not. If you have the source code of the unit, if you have the source code of this method, or if you have the source code of these classes or group of classes or group of methods, if you have the source code, then you're going to do a testing that can be at the level of the source code, that can be at the level of searching in which of the lines, in which of the methods, in which of the classes something is happening, and specifically what is happening. When you have access to the source code and when you want to test the source code, we're talking about white box test. Even though the name is white box, the idea is this transparent box, this idea of, okay, this is my unit, the class, the method, or whatever, and I am able to saw inside. I am able to check, okay, this is the unit, the method, but I am able to read the instructions. And therefore, even though I am testing, I am giving an input and expecting an output, I am following where the execution is going. White box testing. The opposite is black box. Black box, yeah, that is what happened when you do not have access to the source code. What happened if you need to test something that is from another person, from another team, from another company, but they didn't give you the source code? It can be a jar file. It can be a group of files .class versus the .java that you have here. It can be something that is binary, something that is already compiled. You can test it? Yes, you can. In the same way that you test a library. You use a method and you expect some result. You do not know what is happening inside, but you provide an input and you expect an output. I am going to call a method, and that method needs to show me a frame on the screen. I am calling the method, the frame is not on the screen, something is happening. I am doing something wrong, or inside of the box, something is wrong. I am not able to know in which line, in which class, in which method. It's just inside here, something is wrong. I am testing. I can say that this is working or not. I cannot fix it. Maybe I return this to the provider. Here, I can fix it. Black box, if you do not have access to the code. White box, if you have access to the code. Obviously, the important one, since you are developers, since you are engineers, most of the time, this is what we want to cover. This is what we want to do, right? Black box, used as a summary, function level, and the only thing that I can do is to check if work or not. That's it. However, for the white box, I can do a full report of inside what is happening. Inside what is happening. Important things. You know what? We reviewed this in the previous lecture. What can be inside of a method? What can be inside of a unit that make the program complex? And the only thing that you have there, the only thing that can fail is one instruction. An instruction inside of a method can fail. Mathematical operation, a division by zero, whatever, instructions. That is easy to review. The things that make software complex at this level, everything that involves conditions. And I am talking about if else, and I am talking about loops. Everything in which you involve conditions make your software more complex. Why? Because if you have a condition here, what you are doing is flowchart, remember? Two paths of execution. And if you have another condition inside of one of these, another two paths of execution. And if you have something like this, you know what? There are a combination of 1, 2, 3, 4 paths that you need to review. More conditions, more loops, more of these guys, more paths, more combinations that you need to check in order to guarantee that the software works. When you do testing for the tester, the software looks like this. Yeah, flowchart. And the software looks like this because this helps you to understand from the beginning to the end of a particular unit, particular method, how many different paths, how many different combinations of ways to go from this point to this point can happen. In an ideal scenario, in a perfect world, testing is all about running the program and make the program move from this point to this point following that path, and then running the program again and make the program move maybe from a different path, and another test and continue until we cover all the black lines. That could be the ideal way to test software. For this scenario, yeah, you can do it. Think about a real piece of software. The number of paths is by far greater than what I am showing you on the screen. It's impossible to test all the different combinations. When you add a condition, and I am showing you use ifs here, immediately you split in two paths. And if you add a condition above that inside is doing all these crazy things and more crazy things there, think about all the different combinations. Only two conditions is 4 paths, more or less. 3, 4, 5 nested conditions. Things get complicated, very complicated. Okay, so we cannot test everything. What do we test? Well, if you cannot test everything, what we can do is the following. Number one, you can take your piece of software, you can take your source code, and from the source code, let's create a control flow graph. What? A control flow graph. What is that? Do you remember the flow chart? These guys? Okay, what happens if you forget about rectangles and diamonds and you use circles? Really? Yeah. This is the source code. This is a control flow graph. Why we do not use the other? The other is too big, have 2 details. For instance, here, I have these 2 instructions. They are sequential. If they are sequential, I don't care about them. It's use one circle. One circle represents those 2 sequentials, or can be 10. I don't care. It's just one circle. It's sequential. My concern is with the conditions. With the conditions, yes, for instance, this one is a condition. I don't care that it's the condition of a loop. It's a condition. And conditions always, always, always are going to split things in 2. In 2 down, or in 2 because something go down and then I am going to return, or because I need to jump out if the condition is false. Okay, then you have these 2 together, sequentials. Sequentials, I don't care. They are together. It's things that are going to happen one after the other. More conditions. Okay, I have concerns. More conditions. Instructions. There is only one. Yeah, only one. No problem. And then we need to care about, well, the condition open, in some point the condition close. The condition close is this point in which the else finish, right? I do not have curly bracket, but we know that if there is only one instruction without the bracket is one instruction and the if else close. So closing. And this guy here, well, is closing this guy here. So this guy here is the closing of this loop. So this go there. In some point, the condition is not going to cover, so go down. Looks like a flowchart, yes, with particular rules. Two things: diamonds, boxes, I don't care, use circles. Number two, consecutive instructions together. I want this guy to be small. Why do you need that guy? That guy is going to help me to decide what to test. Options. Reviewing this guy, I have 4 options regarding my testing. Mandatory, usually, for any process model, for any piece of software, these 2. Usually, commonly, when you develop software, when you test software, those 2 are kind of the minimum expected. If you want to do high-level testing, like talking about models, V model, in a V model, you can expect more than only those 2. We're going to talk about this one and this one in the next lecture. For today, the only ones that I want to cover, the only ones in your exam is these 2. Statement coverage and decision or branch coverage. You can find both branch coverage or decision coverage, different authors, different names, but they refer to the same. Let's see. Number 1, statement coverage. I have a piece of software, and in that piece of software, a statement coverage asks me to test every single line at least 1 time. Run every single line of your program at least 1 time. This piece of software. If you compile and run this piece of software, can you tell me all the lines are being executed at least 1 time? Yes or no? And hopefully you are reading here my comment. Yes. If you put these lines in a method, I didn't put the method, but if you put this line in a method, this is running and this is running. I mean, there is nothing avoiding A being equal to something, B equal to something. They are going to run. They are inside of the method that I am running. The condition is going to run. Oh, by the way, the condition is true. Okay, the condition is true. It's going to enter. It's going to check that condition. By the way, the condition is true. It's going to enter. All the lines run at least 1 time. That is statement coverage. Wait. What could happen if this is my method, but the value for the variable A is 0? If I put A equals 0, do I have statement coverage running this program? Yes, no, why? No, perfect, why? This line is going to run, this line is going to run, this line is going to run, is false, and because this line is false, this one is not running, this one is not running. So if I am testing this program and I am testing with these values 0 and 5, I am not running all the sentence in my program. Here, there are 2 lines that are not being tested, 2 lines that are not working. So usually what you have, and this is your fancy IDE's help, they give you a percentage of the coverage that you have when you're going to review this when you do the homework this week with unit testing. But when you do unit testing, usually the IDE is going to help you to tell you which is the coverage that you have. So if you read about statement coverage, in my previous scenario, I have 100% statement coverage. All the statements are covered. In this scenario, if we consider that I have these 5 lines and only 3 are running, well, 2 of them are missing. I have something like 3/5% of statement coverage. 100% if all the lines run at least 1 time, period. That is 100%. Lines that are not running are going to reduce that percentage. Now, statement. What about decision of branch coverage? Well, easy. Decision coverage or branch coverage is all about the following. Every single time that you have a condition in your program, that condition should run or should be evaluated true and false. It's not only enough to run the condition one time. Running the condition one time, like in my examples, well, one time is going to be true or it's going to be false, only one of the options. Decision coverage, branch coverage is, you know what? You need to test your program. You need to test your method, your unit, with values, input. By the way, those values, those inputs are test cases. With values, input, or test cases that make the condition true, but also with input values that makes the condition false. Going back to my example here. With this scenario, I show 100% statement coverage. With A and B equal 5, I have 100% statement coverage because I execute all the statements. Why 50% branch coverage? Why 50% decision coverage? Well, because you tested this condition true and you tested this condition true. For branch coverage, you are missing what happens if this condition is false and what happens if this condition is false. But if the first condition is false, nothing is going to be executed. It doesn't matter. I need to test that really if the first condition is false and the program continue with another method, with another things, nothing bad happen. That missing this line, whatever is the line, is not going to cause any problem outside. 100% branch coverage, 100% decision coverage imply running this program with more than one test case, because imply running this program with any combination of values that give me access to the condition, every single one, true and false. True one time, next time, false, or the opposite, and the same with every single one. If I achieve that, then I have 100% branch coverage, decision coverage, and that is the minimum that is expected for a piece of software. This one, with these values, which is the statement coverage that I have. I have a comment here about this. Could you agree? I am wrong. Well, true and true. This is going to be executed. This is going to be executed. Oops, this is not. This is not. Half of the program run, half of the program didn't run. 50% statement. So half of the statement are running, half of the statement are not running. Why? Well, looks like I have conditions here. And the only thing that I test was this one, nothing else. What do I need to do in order to achieve, for starting, 100% here? What do I need to do to achieve 100% statement coverage in this particular scenario? Well, in this particular scenario, what you need to do is, okay, you can run the problem with these values, and that is your test case one, right? But for sure, if you want to have 100% statement coverage, well, you need to run the program a second time with maybe a different combination of values. Values that make this false and therefore make the else to be executed, and then something that make this go in. I can take a test case 2, A equals 0, B equals 0. If I have this test case and this test case, can I improve my statement coverage? It's going to be better because I have 50% here. Run one time, 50%. Can I run this one second time? It's going to improve? It's going to be better? Well, if this is false, now I am going to move to the else, and I am going to run this line. One more line. At least I am in 75%. Notice the test cases, the coverage is not in one test case. The coverage, the percentage that I am showing you is the combination of all the test cases, the combination of all the times that you run the program. I already have this one, and it's not going to change as far as I run the program with these values. Stop, run the program again, now with new values. With those new values, I get a new line that run. Yes, this run again. It doesn't matter. I run here 50%. I run here again one of the lines that I have already executed before, but I get something that I didn't execute before, something new. So I have this, and now this. Oh, this again, and this extra, 75. Can I achieve 100%? Yes, no, why? No. What is the problem? Well, the problem is that in order to execute this print, you need this value to be true, but if you make this value true, here is true, and never execute the one below, just execute this one. And what you found when you cannot get this 100% in a statement is that you have a program in which some of the lines are never going to be used. And the problem is not that you have lines that are never used. The problem is that maybe, just maybe, you make a mistake in the logic of your program. It's not a bug, but maybe, just maybe, the behavior that you want to achieve in the program is never going to happen because, well, who knows? Maybe here you was thinking about a different variable, or maybe here you was thinking about a different value. Something happened. It's an error. You get the errors trying to get full coverage of your program. Statement, branch, statement. All the lines at least one time, branch. All the conditions with both true and false situations. And that's it. I stop with this. This is the last topic for your exam next week. Any question, guys? Good. So see you in 2 weeks, and good luck with your exam next week. See you.